the world's most powerful particle accelerator. The Large Hadron Collider will reopen today after 3 years of being shut down for improvements.
Buried hundreds of feet beneath Switzerland and France, the collider smashes subatomic particles together with enormous energy.
At the CERN laboratory in Switzerland, the world's largest atom smasher cracks the code of our world. Experiments involving the Large Hadron Collider help explain the basic building blocks of the universe.
This is the detector that was responsible for one of the most important breakthroughs in science, the discovery of the Higgs boson.
After many years of waiting, in September 2008, the world's most intelligent high-energy particle collider, the Large Hadron Collider LHC, was complete and ready to work. However, while in use, scientists at CERN made an unexpected and troubling discovery that kept them uncertain about the future. Since then, the scientific community has run wild, with various theories attempting to explain this troubling discovery. What did scientists at CERN discover that has kept them troubled? What does it have to do with humans and the future of science? Join us as we unpack the terrible events currently happening at CERN that causes tremendous concern for scientists to date. World's powerful accelerator machine. The world's most powerful particle accelerator, the Large Hadron Collider, reopens after being shut down for 3 years for improvements. Scientists around the world hope the advanced machine, which is massive, can detect new particles and spark a revolution in physics that could change our understanding of the universe forever. After years of waiting, the world's smartest high-energy particle collider, the Large Hadron Collider LHC, was completed in September 2008, and the LHC is now operational. It is a 27-kilometer particle accelerator down at the border of France and Switzerland. However, recently, CERN scientists made an unexpected and alarming discovery while they were in use. Since then, the scientific community has gone wild with different theories trying to explain the problem. In the 1980s, scientists came up with a great idea, and the goal was to build a large machine that would help study protons, atoms, and electrons. The name of this machine is the Large Hadron Collider, LHC for short. It would be unlike any machine seen before because it would be a masterpiece of human achievement. The LHC became the largest and most powerful particle collider in the world. Before that, they had to be even more powerful than other particle accelerators, so they could study things better. So the plan was to make it the ultimate machine. That is why LHC was designed to be the largest and most powerful particle accelerator of all time. It would have a large ring of magnets and detectors, all 27 kilometers long. After 10 years of tireless work to build this masterpiece, the LHC team was ready to go. In 2010, the first particle collision occurred. It took a lot of energy to take off. It is safe to say it was the biggest discovery at CERN's LHC, the biggest discovery in particle physics. It was the beginning of something magical and was far more powerful than anything before it. It reveals a bunch of fast races smashing into each other and unleashing the visible element. This is happening inside the LHC. The desire to build this powerful machine was the result of the Strategic International Organization, CERN. CERN, the European Organization for Nuclear Research, is a leading organization for international cooperation and research. Its origin can be traced to the post-World War II era. Europe was still recovering from the negative effects of the war and was trying to rebuild its walls due to the need for cooperation. At that time, European scientists began to insist on the need to unite under one umbrella to build the scientific bases of the continent and to build a laboratory where European countries could collaborate on science. They wanted to encourage new ideas and peaceful teamwork. So in 1950, 211 countries agreed and signed a paper called the CERN Treaty to establish this laboratory in 1957. CERN was established on the border between Switzerland and Switzerland. Their main goal was to study the small parts of atoms called nuclei. To do this, they needed large machines called particle accelerators. These machines push small particles very fast, causing them to collide with each other. It helps scientists learn more about how everything in the universe is made. Particles can hit each other fast enough that they combine and then produce energy. At the time, various particle accelerators were proposed, but none were ideal. They all had their limitations, keeping scientists in the dark about certain parts of the universe. So something bigger and better was needed, thus the LHC idea. The LHC started in 1998, and it was a great achievement. Its story is as compelling as its purpose. Thousands of scientists and engineers from around the world worked together to complete it in 10 years. And in 2008, the LHC was ready for testing. To install this machine, scientists had to dig a 100-meter-wide tunnel to bury it. This is the first beam of particles to orbit the Large Hadron Collider, and its purpose was to protect it from the surface and prevent the mountains from interfering. This strategy also saved a lot of money because they didn't need to dig big mines to take a lot of land. It's also safer underground. The LHC smashes together tiny particles called proton beams and studies their effects. But once a year, it turns its focus to heavy ions like lead for a full month. It creates an even more interesting reaction. It's like a special celebration of colors to the machine. To achieve this, the LHC has special points where these particles collide, and 7 detectors to observe and learn new things about the collisions. Scientists use the LHC to test some important and new ideas in particle physics. They are particularly interested in the LHC's ability to find the Higgs boson and check if there are many particles previously seen in Mother Nature. Pushing 2 proton beams together at trillions of electron volts, scientists use the LHC to focus on very small particles called hadrons. Hadrons are not the popular particle structures we know from school. They are advanced forms that exist but are taught to intelligent professionals, such as quantum physicists. These are the very tiny particles in atoms made up of smaller things called quarks. One can think of them as the building blocks of ordinary protons and neutrons. The LHC is named after them because it allows them to create new things. Many of these new particles only last a short time, so they are only visible when they hit the LHC. The LHC is not just an underground machine. Inside it is a large building with important equipment that will enhance LHC discovery. Imagine a room full of high-tech electronic fans and machines that provide scientists with the information they need to falsify or fit a theory of the universe. The LHC does an insane amount of data every year, like 15 petabytes. That's a ton of data, enough to fill 1,000,000 gigabytes per second. That is the reason scientists created a special super-intelligent computer network just for LHC. Scientists have continued to search for the Higgs boson since the creation of the LHC. Just like the hunt for a rare animal, getting the Higgs boson was not successful. The LHC had to make a lot of these Higgs bosons and reveal other interesting elements of the universe so that we could finally see them. But it wasn't an easy ordeal in 2008. The first problem they encountered was a malfunction of the universe. An important magnet of the LHC that caused damage to many parts of the collider. This meant that the LHC was out of service for over a year before repairs were made. But this did not dampen the spirits of all the scientists who believed in its creation. And so, after finally starting up between 2009 and 2013, the Large Hadron Collider is now back online. With this huge machine back in operation, it has revealed several discoveries, but this recent one was terrific. It raises different speculations about the future of humans and science. The LHC's terrific revelation. After the £6 billion project was halted for repairs more than a year ago, the European Organization for Nuclear Research has announced that the LHC has completed its first test run. Recently, the LHC made some really interesting discoveries. One of these discoveries was the discovery of the Higgs boson. After this successful first run, the LHC was put on hiatus so scientists could make one or more additions to improve performance. The upgrades took 2 years to complete and ran until 2015, ready to take scientists on an exciting adventure of discovery. The second round ran from 2015 to 2018, and then took another break until starting again in April 2022. Note that every break is to install more upgrades and new upgrades to the LHC. The third operation of the LHC has started with even more power. This third round is sure to keep us all intrigued until 2026. However, during the third experiment on July 7th, something amazing happened. That left the scientists with unexpected and surprising plans. On July 7th, scientists at the LHC discovered the universe by scanning a strange crack in the Earth's electromagnetic field, Earth's protective shield. To understand the implications of this discovery, imagine the Earth's magnetic field as a big bubble around our planet that protects it. Now imagine a crack in that bubble in full space. The most annoying part of this is that the crack didn't appear for a while. It stayed open for a whopping 14 hours. This is enough time to wreak havoc on the ground. It's like leaving the window open on a stormy night and letting the cold wind come in for 14 hours. This is why the scientists are troubled. This disturbing discovery could mean the beginning of unexplained climate change, but it could mean more. A crack in the Earth's magnetic field releases a flood of solar wind from the sun onto our beloved planet, causing massive electromagnetic storms. The result of this discovery was an incredible aurora light show in the sky. The Earth's magnetic field reverses the storm. Magnetic fields bind the pole of the funnel of gas flows on the daylight side, which is known as the daylight aurora. Some individuals reacting to the crack said that the rift is a gateway for monstrous villains to invade Earth. Because the crack didn't just come out of the blues. It was caused by a phenomenon that scientists have yet to name. However, there is speculation that the crack was caused by something called the Sun's rotational interaction region. Gyres are large structures made of plasma that are created by the mixing of solar winds at different speeds. It's like two rivers coming together to form a big waterfall. When these rings and other things like coronal mass ejections hit the Earth, we see beautiful auroras. In the early hours of July 7th, the collision between the ring and Earth caused a long-lasting geomagnetic storm. The National Oceanic and Atmospheric Administration even said that the storm was caused by an earlier coronal mass ejection. But should we be concerned about these causes? Experts say there is no reason to worry. Earth's magnetic field, like a shield, often deals with these cracks and usually closes them quickly. However, recent events show they can stay for hours. It's like a window left open too long during a storm when it should be closed immediately. Energy entering the shield during these disturbances and cracks can cause problems for our satellites, radios, and electrical systems, but fortunately, there were no major problems. Instead, people in Canada and the US got amazing auroras. There is another development as scientists have discovered a major mystery about the sun and its recent activity around our solar system, which may contribute to disturbances and rifts. The sun is becoming more active, more than they expected this time, which means we will have more opportunities to see the sky lit up in color. However, there are some predictions about the limitations of this huge crusher machine. What discoveries has it made, and what led to those predictions? LHC's eye-opening discoveries. Let's drive back to the biggest collider machine, LHC. One can ask if it is worth the time and resources put into it. Think of it as a giant microscope that helps scientists see even the tiniest bits of our universe. Having discovered a lot about the Higgs boson. This particle was finally discovered on July 4, 2012, by scientists at the Large Hadron Collider LHC at CERN. The LHC confirmed the existence of the Higgs field and the mass-generating mechanism, and thus the standard model of particle physics, the best description we have of the subatomic world. According to CERN, the Higgs boson has a mass of 125 billion electron volts. It is 130 times more massive than a proton. It is also uncharged with zero spin, the quantum mechanical equivalent of angular momentum. The Higgs boson is the only elementary particle that does not have a spin. A boson is a force-carrying particle that appears when particles interact with each other, and the boson changes during that interaction. For example, when two electrons interact, they exchange a photon, a particle that carries the force of electromagnetic fields. And because quantum field theory describes the microscopic world and the quantum fields that fill the universe with wave mechanics, a boson can also be described as a wave in a field. By revealing this particle predicted by the Standard Model, the discovery of the Higgs boson completed this picture of the subatomic world. Beyond this theory, there are still mysteries, such as the nature of dark matter, which the Higgs boson with its unique properties could help solve. The LHC has also discovered 59 new hadrons. These include the recently discovered tetraquarks, as well as new mesons and baryons. All these new particles contain heavy quarks like charm and Earth. These hadrons are interesting to study. They tell us what nature considers an acceptable combination of bound quarks, even if only for a very short time. They also tell us what nature does not like. The discovery of these new particles and measurements of their properties continue to provide important information for testing the limits of the quark model. This, in turn, allows researchers to deepen their understanding of strong interactions, strengthen theoretical predictions, and fine-tune models. This is particularly important for the study of the Large Hadron Collider, since the strong interaction is responsible for most of what happens in hadron colliders. The better we understand the strong interaction, the more precisely we can model these collisions, and the greater our chances of seeing small deviations from expectations that could suggest possible new physical phenomena. The hadron discoveries of the LHC experiments are constantly increasing, mainly from the LHCb, which is particularly suitable for studying particles containing heavy quarks. The first hadron Chi-B3p discovered at the LHC, and among the latest are a new strange accelerated beauty baryon detected by CMS and 4 tetraquarks detected by LHCb. Then, in July 2022, it highlighted a new particle called the pentaquark, which is made of different quarks. Scientists have discovered a subatomic particle called a pentaquark, which is made up of 4 quarks and 1 antiquark bound together. It is an exotic type of particle that is not found in nature and is created only through experiments. The pentaquark has 5 quarks instead of the usual 3 found in regular particles, and it has been predicted to exist for decades. However, it was very difficult to detect until recently. In 2015, scientists at CERN reported discovering pentaquark states, and in 2019 and 2022, they discovered new types of pentaquarks. Pentaquarks might also be produced naturally in the processes that result in the formation of neutron stars. A quark is a type of elementary particle that has mass, electric charge, and color charge, plus an additional property called flavor, which describes what type of quark it is: up, down, weird, charm, top, or bottom. Due to an effect known as color ghosting, quarks are never seen alone. Instead, they form composite particles called hadrons, so their color charges are lost. Hadrons made of 1 quark and 1 antiquark are known as mesons, while baryons made of 3 quarks. These normal hadrons are well documented and characterized, but theoretically, nothing prevents quarks from forming exotic hadrons, such as tetraquarks with 2 quarks and 2 antiquarks, or pentaquarks with 4 quarks and 1 antiquark. The discovery of pentaquarks allows physicists to study the strong force in more detail and helps understand quantum chromodynamics. In addition, current theories suggest that some very massive stars produce pentaquarks when they collapse. The study of pentaquarks can help shed light on the physics of neutron stars. Despite these great discoveries and advances at the LHC, one thing remains constant, and that is that even large instruments like the LHC can run into problems that can reveal problems over time. This time, scientists are making a move to expand the LHC, known as the Large Hadron Collider of Highlight. They started this project in June 2018 to make the LHC better at finding rare things in space. Now, as the 3rd experiment ends in 2025, CERN scientists hope to duplicate the data and perhaps discover even more new things. CERN's LHC is preparing for new adventures with the LHC. They hope that all the investment to upgrade the machine will pay off, And in 2029, after a lot of work, this great machine will smash particles together 10 times faster than ever before. This phase until 2042 will collect 10 times as much data as we can in the third attempt. One might wonder why scientists are pushing for an upgrade on LHC and what the importance is. It has a lot to do with proton collisions. Future upgrade about LHC. What happens in a proton collision is that two protons get close enough to feel each other with some force. Protons are like bags of colored jelly. Inside them are tiny particles called quarks, held together by even smaller particles called gluons. It's like a dance of the smallest pieces of nature. One can imagine it as two bags of jelly beans bumping into each other. Usually, the jellies break and form familiar patterns again. Sometimes something special happens when two quarks or gluons collide. It compresses all its energy into a small point and then lets it explode. In these rare moments, scientists learn the secrets of nature. As exciting as it sounds, it is not so easy to detect or observe. Why? This is because protons collide with each other an incredible 40 million times per second, and each crash makes the image 20 times larger than the smartphone. Of those 40 million explosions, most are normal. There is one special Higgs boson event when scientists process all this data with a trigger. This is an elegant computer system that captures the most interesting collisions every second. After picking them up and confirming their presence, scientists focus their research on them to learn the secrets of the universe. Some of these mysterious particles can be very heavy. They are like the great masters of the universe, bursting into smaller particles with enormous energy. Scientists speculate that during the third run of the LHC, it may no longer find these large particles. Instead, it may find hints or clues, such as a treasure map, instead of the treasure itself. These clues can lead to greater discoveries in the future. Some of the new particles may even merge with dark matter, but they are so elusive that they are rarely seen. Scientists use the LHC to track particles and pick out those that move strangely and give hints of the invisible. But sometimes these signs are too faint to detect. It's like trying to hear a whisper at a loud concert. But CERN scientists have hinted to the world 3 times that the upgrade will speed up the detectors to better pick up these faint hints, though not all of them. They are currently planning to build an even bigger machine called the Ring Collider of the Future. This massive particle smasher could cost between 9 and 21 billion. But not everyone agrees with that plan. Some think the scientists should invest in other big scientific ideas, like a giant radio telescope hidden inside the moon or space instruments to detect gravitational waves. The Future Circular Collider FCC study is developing plans for more powerful particle colliders that could continue the phase of the Large Hadron Collider LHC when it reaches the end high luminosity phase. The study, expected to be completed in 2025, will examine the technical and economic viability of the FCC at CERN, including geological feasibility, environmental impact, infrastructure design, civil engineering, and detector and R&D technologies to ensure the effectiveness and sustainability of the proposed project. The new tunnel is designed with a circumference of 90.7 kilometers, an average depth of 200 meters, and 8 surfaces for up to 4 experiments. The tunnel would initially house the FCCE, an electron-positron collider designed for precision measurements, offering a 15-year research program starting in the mid-2040s. A second machine, FCCHH, will then be installed in the same tunnel, recycling the existing infrastructure, similar to when the LHC replaced the LEP. FCCHH plans to reach 100 turboelectric vessel collision energy, colliding protons as well as heavy ions, and operate until the end of the 21st century. Renowned physicist Sabine Hossenfelder argues that the massive new machine may not reveal the secrets we hope it will. It's like buying a super telescope that might not show us new stars. But with 3 and maybe even 4 runs planned for the LHC, there's a lot to look forward to. It is as if we are in the middle of an exciting cosmic puzzle that reveals clues one by one. Each step promises further discoveries. However, according to geniuses like Max Laughlin, we may be in trouble. Max Laughlin's theory suggests that experiments by the European Organization for Nuclear Research caused humanity to move to an alternate universe, resulting in a kind of Mandela effect. The disk collisions at CERN may have somehow caused a ripple in space-time, making us a slightly different version of our universe. The Mandela effect, named after the mistaken belief that Nelson Mandela died in prison in 2013 instead of the 1980s, is a phenomenon in which many people remember events more likely or differently. The people who proposed this theory believe that these false memories are not just memory errors, but signs of a transition to an alternate reality, where we can see what they are in research, and have been viewed with skepticism by many scientific communities. CERN's experiments are truly cutting-edge and explore the limits of our understanding of the universe. There is no concrete proof that they have the power to send us into a parallel reality. When such dangerous theories are out there, the masses start to worry. This leaves room for the important question: what happens if something goes wrong at CERN? And are there ways to keep CERN safe in the future? To answer these questions, CERN has assured the world that if something goes wrong at CERN, they can handle it. Safety is a watchword at CERN, integrated into all aspects of its operations. First, strict protocols are in place to minimize radiation. Personnel working with particle accelerators and detectors are equipped with dosimeters and radiation areas, so accidents are strictly controlled. Constant construction and protective materials are used to contain the radiation. Another important issue is chemical safety and careful handling and disposal of hazardous materials. The facility also prioritizes electrical safety and fire prevention, conducting regular inspections and ensuring that all electrical systems meet international standards. In addition, CERN emphasizes its safety. Comprehensive training programs and safety exercises prepare personnel for emergencies, including fire, chemical, or radiation spills. In addition, an extensive medical service is available on site, which enables rapid treatment of health-related problems and environmental precautions. Recently, concerns have been raised about a possible fusion reaction in the LHC carbon radiation dump. However, CERN says that previous safety assessments by regulators in CERN's host countries, France and Switzerland, have already addressed the safety of the LHC radiation dump. This explains that fusion reactions require external pressure to compress the material. This condition is not fulfilled in the LHC radiation dump. However, it was explained that such nitrogen tanks do not exist, and even if there were, fusion would not occur due to the lack of pressure. Assmann et al. Wrote a technical memorandum explaining that for fusion reactions to occur, external pressure is required to compress the material. This condition is not met in the LHC beam dump. However, it was clarified that nitrogen tanks, which were mentioned in the memorandum, do not exist, and even if they did, fusion would not occur due to the absence of compressive pressure. Based on new data and information gathered, a safety group called LSAG re-examined a study conducted in 2003 about the safety of the LHC, a large science machine. They agreed with the earlier study that the LHC is safe and there is no need to be concerned. Furthermore, they stated that whatever the LHC does, similar events have occurred in nature many times before. CERN's Scientific Policy Committee, a group of external experts, also concurred with the Legal Sector Affinity Group LSAG report. What do you think about CERN and LHC? Let us know in the comment section. Also, don't forget to like, share, and subscribe to the channel for more related content.